Okay, not too surprising. Let's put the second one. Okay, looks like I can fit around 2, but maybe if I just try to put in a third one, maybe something will change. So I can fit around 3, but maybe I can fit in another one. Okay, maybe I can fit in another one. Alright, maybe I can fit in another one. Maybe I can fit in another one. Alright, this is 8. This is balloon number 8. Now raise your hand if you think I can fit in all 10 balloons, the last 2. A lot of people are changing their minds. So the reason I ask again is because in science, you want to change your mind, especially when you're presented new evidence. The new evidence was observations that I could fit these balloons inside. But now I want us to make some observations. What do people notice about these balloons? Raise your hand to tell me one thing that you notice. Yes, my friend. They got hard. What tells you that they got hard? So they look wrinkly. That's a great observation. What's another observation? They started to get small. So maybe the gas left the balloons and they got small. All right. What's an observation?
When they went in, they made like frosting sound.
Ooh, they made sounds. So my friend here, notice a sound that it made. Yes, my friend on the stairs.
I thought in there
I did fit all the balloons in. Absolutely right. Do we have another observation in pink?
They're really squishing the water. I can't even see the water anymore. I bet now it's going to turn to solid.
Oh, so maybe they got solid. Interesting. So maybe they're not even all in the liquid nitrogen right there. One last observation.
I think it's stressing. The first one is stressing so hard. I think it's losing the air and it's squishing the top.
Oh, so maybe it's losing the air and squishing them behind. All right, so raise your hand. I've gotten that twice now. Raise your hand if you think the balloons lost the air inside of them. Raise your hand if you think that. All right, I see a few hands. Now raise your hand if you don't think the balloons lost the air inside of them. Okay, I see a few hands there. Now raise your hand if you don't know. I see a lot of hands there. In science, you absolutely want to say, I don't know. That's actually why we conduct experiments. That's why we ask ourselves questions, is to learn. And how we're going to learn is by once again making more observations after I take the balloons out. So I'm going to take these balloons out, and again, we're simply making observations using all of our senses. Alright, I'm hearing a lot of great observations. Alrighty. So raise your hand if you thought the balloons, or if you think all the balloons lost their air. Not as many people raising their hand now. Again, it's all right to change your mind. We do have a few hands though. All right, so the balloons did not lose their air, but the balloons did change. What are some observations we can make about what happened to the balloons? I'm not looking for an explanation, just things that you noticed. Just one thing you noticed. So when I put them inside, the balloons became compressed, and when I took them out, they expanded again. That's a good observation. What is another observation? When they expanded, they were making crackling noises. Yes?
You don't want to do it?
Oh, maybe the air was making the balloons solid. Interesting idea. Last observation.
So you know how when you take stuff out of the freezer, it's solid, and when you put it in your hand, it was like that sound.
Ooh, it's kind of that crinkly sound that you would get from pulling something outside of the freezer. Great observations, my friend. So what happened here was when I put the balloons inside. All of those molecules of air inside of the balloons, well, they dropped in temperature. They lost heat. They took up less space, causing the balloons to shrink. And they stayed shrunken while inside of the liquid nitrogen, but after I pulled them out, those air molecules gained more energy. They got heat from the room, and then slowly they started to expand more, and they actually caused the balloons to expand. So again, nothing really changed about the balloons. Their composition is about the same. It's simply the temperature changing how those molecules move. So I've been putting in inflated balloons, but I want us to put in a deflated balloon. So I have one right here. Can someone raise their hand and tell me in what state of matter is this balloon right now? In what state of matter is this rubber balloon? Yes, my friend? It's a solid, absolutely. So believe it or not, this is a solid. It's not a very rigid solid because it's bendy and stretchy. In fact, rubber has long chains of polymers that allow it to slip and slide past each other, giving it this kind of rubbery texture. But after I let go, it kind of returns to its original shape. So what would happen if you were to supercool this? Would it change in any way? Let's find out. So I put that balloon inside there. I'm going to make sure it stays nice and submerged. Think about how it might change. Can you super freeze a solid? Does it become more solid? So let's find out. Now for this, we're going to make a very important observation. I want us to all focus right here. I'm going to put the balloon here soon after I take it out. I'm going to put it actually on our camera to make sure that everyone can see. So there we go. Making observations. Here we go. So it might not look the same. Let's see if it behaves the same. Do normal balloons do that? No, they don't. So what happened here is when I super froze that balloon, it was still a solid. It was a solid the entire time, but it went through what we call a